A shooting star is a star that falls from the sky. I have to admit that I was convinced such stars existed. It was much the same belief I had in Santa Claus. The shocking truth was that these stars aren't actually stars. As I gazed into the night sky's sparkling emptiness, another meteoric body attempted to pass through the Earth's atmosphere for the umpteenth time. This is a daily occurrence. Every day, millions of cosmic bodies rush to our planet's surface. There is not much going on. Despite the absurdity of the expression, real falling stars exist in our universe. Ladies and gentlemen, buckle up. We set out once again into deep space. Mira, also known as Omicron Ceti, is our new friend. It is 700 times bigger than our sun's diameter. It is a star even stranger than Betelgeuse, our heroine in the previous installment. Hipparchus, in 134 BC, and the testimony of Chinese astronomers in 1070 are the first to mention this beauty. Its almost supernatural properties were only discovered recently. The discovery of a new star type by David Fabricius, a pastor and astronomer, was accidental. It happened on August 13, 1596, without Fabricius realizing it. He was watching Mercury at the time. He was actually trying to determine the distance between Mercury and the star nearby, which he thought would be at an apparent magnitude 3 in the constellation Cetus. It was a new discovery for him and was absent from all of the stellar maps or globes. Although maps and globes weren't as precise in the old days, disregarding some bright stars was commonplace. Fabricius started to watch the stranger and, lo and behold, its brilliance increased to a magnitude of 2. This immediately impacts the optical properties in the stellar atmosphere. The atmosphere becomes transparent as the temperature rises. Chemical compounds begin to decompose. Hot hydrogen masses play a significant role in the phenomenon. They erupt into the atmosphere during peak brightness periods and increase the star's brightness. It became the brightest star of its constellation at the end of August. The star then began to fade in September. It disappeared completely by mid-October. Fabricius was certain that this was a new, different star and stopped watching. To his surprise, Fabricius came across the great mystery traveler 13 years later, on February 15, 1609. To be fair, Johann Bayer, an astronomer, noticed it 6 years earlier in 1603. The data were entered into his star atlas, but he didn't know the super properties. The star had reached a stellar magnitude already by this time. Over the next few decades, astronomers around the globe began to closely follow Omicron Ceti. Jan Hevelius, a Polish astronomer who observed Omicron Ceti from 1659–1682, named it Mira. This Latin name means amazing and is a translation of Latin. He was right. This star is incredible. It is often so dim that even an amateur telescope can't see it. Its peculiarity means that it can become the brightest star of the constellation Cetus at specific times. These are the so-called peaks. It fades and then becomes almost invisible. The cycle continues, with the same result every time. By the middle of the 17th century, scientists had discovered that the miracle was a new type of variable star with a long period of brightness and a large amplitude. Simply put, Mira is a star whose brightness changes constantly, but with some irregularity. For those not familiar with the concept, the apparent magnitude of a star is what makes it sparkle. This is the same as luminosity, or even simpler, brightness. Smaller numbers are brighter than larger ones. In just 332 days, Mira's brightness increased by 3.5 times. It can be seen almost invisibly through a telescope at magnitude 10. At magnitude 2, it becomes the brightest star in its constellation. There is no pattern in her behavior, as I stated. In fact, Omicron Ceti's brightness range and period change constantly and are completely unpredictable. Omicron Ceti was once at the 9th magnitude, which is quite dark. She then rose to the 5th magnitude, and then she went back to the 9th magnitude. Omicron Ceti also faded to the 10th magnitude, but she then rose to her highest magnitude of 2. The fluctuations in luminosity can be quite staggering, as you can see. What does this all mean? At its lowest brightness, Omicron Ceti's luminosity, also known as Mira, is almost equal to or slightly lower than the luminosity of our Sun. This means that Mira's brightness will exceed that of the Sun 700 times at maximum and can sometimes surpass it by up to 1,500 times. This is because red giants' surface temperature changes when they pulsate. As a result, their luminosity fluctuates as well. The study of Mira and other variable stars like it has helped scientists better understand the life cycles of stars and the complex processes that take place within them. While Mira's behavior may seem erratic and unpredictable, it offers a unique window into the inner workings of the universe and the celestial bodies that inhabit it. So, the next time you gaze up at the night sky, remember that there is much more going on than meets the eye, and the wonders of our universe are truly boundless. This is at least the most plausible explanation I've found for Mira Ceti's amazing changes. There is more. In 1919, scientists discovered that there was a second spectrum superimposed on the Mira spectrum. It is a very, very hot star. 4 years later, a satellite was found very close to Mira. Mira B, a white dwarf, is the star that's so hot, it literally eats its larger neighbor. Little Mira B orbits giant Mira once every 400 years. Since Fabricius, the satellite has only made one complete orbit around Mira. About 70 astronomical units is the average distance between the main star and the orbit of the white dwarf. This is 70 times the distance between the Earth and the Sun. The best part is that the dwarf star, which is smaller than her larger companion, has similar properties. The brightness of the white dwarf changes regularly. This happens for many other reasons. Mira B is equipped with an accretion disk through which Mira B interacts with her main star. This allows Mira B to absorb stellar matter from her larger sister. The satellite's luminosity also changes due to the uneven supply. The brightness value for the dwarf is between magnitude 12 and 9.5 on average. The measurement of brightness changes in stars of this kind requires astronomical expertise. Imagine that scientists must take into consideration and superimpose all fluctuations in brightness during 13 years to determine the amplitude oscillations in luminosity for this star. Their duration is measured in minutes. We are now done with the last few delicious tidbits. GALEX, or the Galaxy Evolution Explorer Satellite, is an orbiting ultraviolet space telescope that was launched in 2003. GALEX found a tail of matter from Mira A's outer sphere, similar to a comet. This huge tail of material is approximately 13 light-years long, which is the distance between our Sun and the nearest star, approximately 4 light-years. This is a very long tail. The stars of our galaxy slowly rotate around their center. They move at the same speed and direction as interstellar gases. Mira, however, is tearing through the galactic cloud at 130 Kelvin per second. Mira's matter is simply blown back and forms a bow-wave tail made of compressed gas. Calculations show that every 10 years, the star loses a mass equal to the whole of Earth. It took at least 30,000 years for the star to form this tail. It would be amazing to see this up close. I'm sorry, but to make this happen, I would have to be a god. These images from the GALEX telescope clearly show a huge swelling in front of the star. This is the area of the shock wave. This is what happens when a boat cuts through water at high speed. You could also see it in front of a supersonic bullet. This is the matter that has been thrown by the star after it collides head-on with interstellar gas particles. This is the end of my story for today. To conclude, I would like to mention that we have currently discovered over 46,000 variable stars in our Milky Way galaxy and approximately 10,000 in other galaxies. This is just the beginning. Every year, more stars are discovered. If you don't like the channel, please leave a comment. Subscribe to the channel. Please share this channel with your friends and other well-behaved acquaintances. Until next time.